All right. Okay. So good morning, students. Am I visible, audible, and my PPT sharing with you? Can you see these three? Am I visible, audible, and is PPT visible to you? Yes, students. Is my PPT visible? Yes, students. You need to tell. Oh, yes. Okay. Okay, Damini. Okay. Okay. So we are going to start the class. So as we know that this is a special histological techniques in focus with immunohistochemistry and molecular pathology, and the subject code is B21 MSH716. Okay, so this is the subject code and the subject. So as we know that we are going with this histological techniques, and so far we discussed about the difference between the histopathology and immunohistochemistry. So in immunohistochemistry, we will ensure to retrieve the antigens with a special fixation. Then we will target these antigens with the help of specialized antibodies, and we will visualize the antigen of interest under the microscope, special microscope. So in immunohistochemistry, we can able to localize or we can able to visualize in the cells. So that is the basic difference between the immunohistochemistry from our histopathology. So we have seen this introduction and this principle of immunohistochemistry. So here we are combining the techniques of histopathology, immunology, and the chemistry to get this to visualize the products that we want in the tissue. So this is the basic principle of immunohistochemistry. First, we will try to get the things, then we will go with the primary, secondary, and conjugate. Upon where we will get the color, that color will be visualized under the microscope. So this is the basic principle of immunohistochemistry. Then we discuss about the uses of immunohistochemistry. So some uses of immunohistochemistry include identifying replicating cells, locating cells that are signaling, locate apoptotic cells to identify the activation states of the cells, to identify the different types of cells in the tissues, and to examine the cytoskeletal structure of the cells, and to detect the prognostic markers of cancers, to detect tumors of uncertain histogenesis or origin, to predict the response of therapy, to identify various types of infections to the tissues. In genetics, we can able to locate all types of genes that interest depending upon the criteria. And we can also use immunohistochemistry for the study of neurodegenerative disorders such as muscular dystrophy. We can also study the brain traumas, and even muscle diseases can be studied with this immunohistochemistry. So these are the few applications of immunohistochemistry. Okay, so other things we discussed, right? Amyloidosis, dementia, muscle diseases can also be detected with the help of this immunohistochemistry. Okay, so this is what we discussed so far, and we had a brief session on the research aptitude, the role of research in masters. And we discussed about the general immunohistochemistry protocols. So what are the three important steps that we will undergo in immunohistochemistry? So the three important steps are tissue preparation, pre-treatment, and staining. Tissue preparation include fixation, sectioning, pole mount preparation. Pre-treatment include antigen retrieval, inhibition of endogenous chemicals such as peroxidase, then blocking of non-specific sites. So these are the three steps we will we will undergo in pre-treatment. Then staining. Staining we already know. Immunohistochemistry is staining, the fluorescence staining, primary, secondary antibodies, and getting colors and visualizing under the microscope. Okay, so these are the important three steps in immunohistochemistry. So tissue preparation, pre-treatment, and staining. So coming to the first, let us go with this tissue preparation. So in the tissue preparation, first we have fixation. So let us focus on what is this fixation, types of fixation, factors are responsible for fixation, and methods of fixation, and the classification. Fixative classification we can see in today's lecture. So are you following me, students? Is there any issues so far? Are you following me? Everyone? Alexis, Damini, Deepika, everyone. Are you following me? Jaspinder. Yeah, I got a reply from Damini. Okay. Okay. So coming to the fixation. So yeah. So fixation, we already know fixation is a process of preserving the tissue by forming cross links, chemical cross links among the proteins, so that the proteins will coagulate and the proteins will they will form cross links. So the tissue will become in lifelike state. So we have two types of methods of fixation. We have chemical fixation and physical. Chemical we have immersion, perfusion. Physical we have freezing and drying. So in layman's definition, fixation is a process where we will prevent the decay of any tissue. Okay, that can be stated as a fixation. So as I stated, so here we have proteins, and proteins will form cross links among the proteins, and that will cause the preserve the proteins. That is the idea of fixation. We can take anything. We can take either formaldehyde, we can take alcohol. So that depends what type of fixator we need to take, depends upon the criteria that we want to that criteria depending upon the test we want to perform. Okay, so certain aims of fixation include to prevent autolysis and putrefaction of tissue. The fixator should be rapid and even penetration. It should be able to preserve and tissues in lifelike state. It should have elements that are to be demonstrated must remain in maximum concentration. That means it should not destroy the elements that we want to detect. It should be labile. It should be stable and labile. It must be rigid. It must allow staining, further staining, and it must optical contrast, and it should have proper clarity upon observing under the microscope, and it should allow the tissue to preserve for a long time. Okay, so these are the few aims and objectives of fixation. So an ideal fixator should have, there are certain properties that we need to it should be cheap and easily available. It should be stable and safe to handle. It should be rapid in action. It should cause minimal loss to the tissue. It should not bind to the reactive groups within the tissue. Okay, and it should not. It should have even penetration within the tissue. It should be able to retain the normal color of the tissue, and it should not impart its own color to the tissue. Say, for example, if fixative is in yellow color, upon fixing or upon immersing the tissue in this fixative solution, that fixative color must not impart to the tissue. Okay, the tissue should not become to yellow or whatever color the fixative is. So such type of fixative we need to take, but so far there is no single fixative that can able to fulfill the criteria of an ideal fixative. There is no such thing as ideal fixative. Each and every fixative has its own pitfalls, okay, its own advantages and disadvantages. So that is why choosing the right fixative is an art. So we need to choose the right fixative depending upon the criteria that we want. Okay, so choosing the right fixative is also an important task before fixing the tissue. Okay, so and the amount of fixative. So usually the amount will be 15 to 20 times greater than the volume of the tissue. Say for example, if I'm taking 1 gram of tissue, then I need to take around 20 ml of fixative solution. Okay, I need to suspend this 1 gram of biopsy material in the 20 times volume. That means almost 20 ml of fixative we need to use. So that is 1:20 ratio. Okay, so the volume will be 1:20 ratio. Then there are certain things that will determine the rate of fixation. I hope you know what is the rate of fixation. That means it is the time taken for the tissue to get preserved, tissue to get fixed, the proteins within the tissue get fixed. So the time, the longer the time, okay, if the time is prolonging, then the overall tissue processing will be it will be prolonged. So what factors we are focusing on this fixation time? What measures we can take to reduce this fixation time, to fasten up the procedure? So let us see few factors that contributing to fixation. One is temperature. So at high temperatures, the rate of penetration of fixation will be higher. So fixative solution will penetrate deep into the tissue at higher temperatures. So if we want to have a rapid fixation, then we need to adjust the temperature. Higher temperature, fast fixation. Lower temperature, slower fixation. Okay. Then the speed of fixation. So the speed of fixation also depends upon the specimen size. If the specimen is large, obviously the fixation will be slow. If the specimen is small, then the fixation time will be fast. Then other factors that include the size of the tissue, then a tissue covered by large amount of mucus. Yeah. Say for example, if you get a tissue from biopsy from nose or from gut, okay, intestine or stomach, then these tissues are excessively embedded with this mucus material, and mucus will act as a natural barrier, and it will prevent the fixative solution to get inside the tissue. So such mucus containing tissues will take more time, or the rate of fixation will be slower in mucus containing tissues. Okay, then tissues covered with blood or organ containing blood will be have slow fixation rate. Then fatty acids and lipomatous tissues will fix slowly. Then fixation can be accelerated by agitation, and fixation can also be accelerated by increasing the temperature. So we already know that by increasing temperature, the rate of penetration of fixative solution will increase. So the amount of time required for fixation will be overall reduced. But what is this agitation? So we have this second approach where upon suspending this tissue in the fixative solution, we will constantly shake the tissue. So with this constant agitation, the rate of penetration of fixative solution will increase. So that is how the agitation will facilitate to enhance the speed of fixation procedure overall. Okay, so agitation is very important. Then next one, methods of fixation. So as we already discussed, there are two methods of fixation. We have physical fixation and chemical fixation. So physical include heat fixation, microwave fixation, freeze drying. Okay, freeze drying and vapor fixation. So let us focus on this vapor and freeze drying fixation. Okay, so and we have chemical fixatives. So we have various types of categorized. So we have various classifications of these fixatives. Let us have a quick overview on this all fixative and their types. Okay, then we can go to this specific fixatives in immunohistochemistry. So depending upon the chemical nature, we have four types of fixative solutions. Okay, we have aldehydes, oxidizing agents, protein denaturating agents, and other cross-linking agents. Okay, aldehydes include formaldehyde, glyceraldehyde, arsenine, and glycoxyl. Whereas oxidizing agents include oximum tetroxide, potassium permanganate, potassium dichromate. Protein denaturing agents include acetic acid, methyl alcohol, and other cross-linking agents such as carbamamides and other techniques are there. Okay, so depending upon chemical nature, we have three types of chemicals: aldehydes, oxidizing agents, and protein denaturing agents. So yeah, now how these chemical fixators are further classified? So the chemical fixators are further classified depending upon their complexity. Okay, if the fixator solution has only one component, one ingredient or one component, such fixators are called simple fixators. If the fixator solution has more than one component, like it's a mixture of any two components, such fixators are called compound fixators. So simple fixators, we have formalin, mercuric chloride, osmic acid, picric acid, acetone, ethyl alcohol, osmic tetroxide, and osmic acid are few examples of simple fixators. Then compound fixators. So as the name suggests, compound fixators, more than one ingredient, more than one fixative composition, hence they are called compound fixators. Now, depending upon their usage, these compound fixators are further differentiated into four types. Okay, very important. Compound fixatives, depending upon their usage, depending upon the target organ or cells, these compound fixators are further divided into four types. One is classical histopathological fixative, which is called microanatomical fixative, which we will use in histopathology. And that microanatomical fixative is formalin acid, natural buffer formalin, xanthous fluid, and Bowen's fluid. Then cytological fixative. So these cytological fixators are used for preserving single cells. The cells are preserved by these cytological fixators. Now, within the cell, we have two important portions. One is the nucleus and the other one is the cytoplasm. If there will be some situations where we need to preserve the chromosomes within the cell for karyotyping, we need to study the number of chromosomes in the cell because we have some euploidy, aneuploidy conditions. Okay, like Klinefelter syndrome or Down syndrome. There are many Edwards syndrome. There are many diseases that occurred due to genetic diseases that occur due to chromosomal variations. Such chromosomal studies can be studied with the help of suspending the cells in a cytological fixative. To be precise, we need to use nuclear fixatives. Nuclear fixatives will preserve the nucleus, the chromosomes of the cell. So we have a few nuclear fixators such as Cornell's fluid, Clark's fluid, Newcomer's fluid, and Fleming's fluid can be used as a nuclear fixative in order to preserve the chromosomes or nucleus of the cell. Whereas if you want to study the cytoplasmic components such as mitochondria or any this endoplasmic reticulum ribosomes, then we will opt for cytoplasmic fixative. And one of the best cytoplasmic fixative that we have is Champis fluid. So Champis fluid can be used as a good cytoplasmic fixative. Then we have other things, okay, records fluid, formalin, formal calcium, etc. Anyway, then last and final will be histochemical fixatives. These are the fixatives which we will extensively use in immunohistochemistry. Okay, in immunohistochemistry, we will use this in histochemical fixatives. What are those? We have cold acetone and ethanol. Both cold acetone and ethanol are extensively used in freeze drying technique. So in freeze drying method of fixation, we will use this cold acetone and ethanol. Okay, so they are the primary ingredients or primary fixators that we will use in immunohistochemistry, cold acetone and ethanol. So let us see what are these two. Okay, so according to your syllabus, they have given two types of fixator students. They discuss about spray fixation and the other one is a vapor fixation. Okay, vapor fixation, and they discuss about freeze drying. So vapor fixation means here we will subject the tissue to the vapors of this formaldehyde. Upon subjecting the tissue to the vapors of formaldehyde, we can able to preserve the tissue. We can able to fix the tissue. Such method of fixation is called vapor fixation. So this can be utilized for both histology and cytology samples. The vapor of chemical is used to fix either a smear or tissue section. The vapor converts soluble material to insoluble material, and these materials are retained upon the smear comes in contact with liquid solution. Anyway, so overall, we will coagulate the proteins and we will prepare the cross links among the proteins and we will fix the tissue. So for that purpose, we will use vapors of formaldehyde, osmium tetroxide, glyceraldehyde, and ethyl alcohol vapors can be utilized for vapor fixation technique. Okay, so why vapor fixation is important? Vapor fixation is extensively used for delicate tissues, the tissues that can easily damage by defragmenting by submersing or immersing in liquid solutions, or the tissues that are fragile. Such highly fragile tissues will be subjected to this vapor fixation. Since it is just a small vapor which we are subjecting towards them, so there will be very minimal damage to the tissue, and tissue can be able to withstand more, okay, with vapor. So fragile tissues will be subjected to this vapor fixation method. Okay, so this is the idea. So we will ensure whether it has a formaldehyde, glyceraldehyde, osmium tetroxide vapors or acetic acid vapors, and we will keep the tissue above the vapors. Okay, so the vapors will get vapors will fix the tissue, and this need to be done in the laminar hood. Okay, because these vapors are really irritating and they are also carcinogenic in nature. So we need to perform this vapor fixation only within the laminar hood. Okay, laminar airflow hood. Like we have an advantage of laminar airflow. So this laminar airflow hood will it will absorb all the fumes that are accepted. It is a uniform system, so the vapors will be reabsorbed by this hood. Okay, so this vapor fixative is used for a demonstration of glycogen deposits within the tissue, and the vapors, we can achieve these vapors at a 60 to 70 degrees centigrade, and we need to subject the tissue for almost 2 hours over the vapors of this particular fixative. Okay, so for 2 hours we need to suspend the tissue at the temperature of 60 to 70 degrees centigrade to get an ideal fixation. Okay, so this is all about the vapor fixation. Then we have the second concept called freeze drying. So in freeze drying, we will solidify the tissue by freezing the tissue by subjecting the tissue to very low temperatures, -60 to -80 degrees centigrade. By subjecting to very low cryo temperatures, we can able to freeze the tissue instantaneously, so that the all enzymes, proteins, lipids, subcellular matrix proteins, everything will be preserved in their lifelike state without even altering the peptide structure. In freeze drying, there won't be involvement of any fixatives. It is a direct freezing of the components in their state. Okay, that is a major idea of this freezing, drying, freeze drying fixation. Okay, so this is very useful for research studies, particularly for immunohistochemistry studies. Okay, so here the tissue is cut into thin sections, and we will immerse this tissue in a coolant solution. Say, for example, we will take one sucrose solution, we will suspend the tissue, and we will subject it to the liquid coolant. So this liquid coolant, this process is called quenching. Usually we will use liquid nitrogen, propane, or isopentane. In order to liquefy nitrogen or propane or isopentane, we need very low temperatures. Only at very low temperatures, these three components will be in their liquid state. So by subjecting the tissue to this cryo preservative, cryo substances, they will freeze instantaneously. And this freezed block can be used for obtaining sections, and these sections can be subject to the further staining. So this is the idea of a freeze drying. So for this purpose, we will use obviously a freeze dryer. So this is a modified refrigerator with very low temperatures. This can achieve almost -30 degrees centigrade, and it will be a vacuum chamber. So we will perform this freeze drying with this vacuum chamber cryo refrigerator. We will use this. Okay. So what are the advantages of okay, so what are the advantages of this cryo freeze drying? So it is very excellent for enzyme studies. There won't be any change in the proteins. There won't be any shrinkage of tissue, and it can also able to preserve the glycogen deposits within the tissue. So these are the major advantages of the freeze drying. But yes, there are also few disadvantages. One of the disadvantages, the tissue morphology won't be as great as classical histopathology. Okay, so classical fixation. So the morphology will be slightly blurry, but still it is sufficient for us to study the preliminary stages of the cell. Okay, to understand the basics of the cell can be identified with the help of this freeze drying. So freeze drying is very essential in case of rapid analysis, rapid histological analysis, okay, such as during emergency or in critical conditions such as in surgery. uh, we can opt for this freeze drying technique for getting the sections out of the cell or tissues. Okay, so this is the major advantage of this freeze drying. Okay, so let me go to the next slide. So yeah, as I stated, small pieces of tissue will be instantaneously frozen by immersing in isopentane or propane. Isopentane mixture cooled to -150 degrees centigrade with liquid nitrogen. This prevents formation of ice crystals and can damage the tissue. So the tissue is rapidly transferred to high vacuum drying apparatus. Okay, then when drying is completed, within 1 to 3 days, the section is embedded in a paraplast. Not 1 to 3 days, it can even we can able to achieve within 10 minutes also. Okay, the specimen, there is a small procedure where we can able to freeze it. Okay, so you can go through these notes, it's not a big deal. Now let us have a quick summary of all the fixators. So as I stated, we have this microanatomical, let me take one more. Where is this? Anyway, yeah. So as we already discussed, microanatomical fixators, these are compound fixators. So we have microanatomical fixators such as formalin buffered glutaraldehyde fluid and formal calcium can be used as a microanatomical fixator. Then cytological fixator, we have two types of cytological fixator. If you remember, we have nuclear fixators and cytoplasmic fixators. Nuclear fixators are Carnot's fluid, Clark's fluid, Fleming's fluid. Whereas cytoplasmic fixator is Zancker's fluid, Champy's fluid. Then histochemical fixative. So in histochemical fixatives, we can use formal saline, cholecystone, or absolute alcohol can be used as a histochemical fixative. Then simple fixatives. So simple fixatives include aldehyde oxidizing agents, protein denaturing agents, and some other picric acid, nitric acid can also be used as a simple fixatives. Okay, this is just a summary slide, not to worry. But yeah, this is also metallic fixators. We have mercuric fixators, chromate fixators, and lead fixators. Okay, then picric acid and alcohol fixators. Now, this is what I want. The target substance and the type of fixators we will use. Say, for example, if we want to, if our target is proteins, if we want to fix the proteins, then the ideal fixator we can opt will be neutral buffered formalin. If we want to preserve carbohydrates, then we have a modified fixator such as Heidenhain-Sousa fluid, buffered glutaraldehyde, or even formal calcium can be used as a fixator of choice for preserving the carbohydrates. Sorry, it is not fat, it's carbohydrates. Then lipids. Lipids can be preserved by subjecting them to glutaraldehyde or simum pectoxide. Glycogen can be preserved by Carnot's fluid or Boyne's fluid. Biogenic and amines, okay, the amines of this protein amino acids can be preserved by neutral buffered formalin. And myelin sheet in nerves, so the lipid deposit or the myelin sheet of the nerves can be uh, fixed or preserved by subjecting them to the Fleming's fixation method, Fleming's fluid. Okay, so few other things include bone marrow biopsy. Usually, bone marrow biopsy will be suspended in the Zenker's fixative. Bone marrow aspiration will be in Zenker's formalin or Haley's fluid. Lymph node, spleen, bone marrow, and hematopoietic tissues will be subjected to BFA fixative. Chromaffin tissues or adrenal, like adrenal medulla mitochondria, Golgi apparatus will be subjected to cytoplasmic fixative such as auth fluid. And renal biopsies will be subjected to neutral form of formalin. Then testicular biopsy will be subjected to Bowen's fluid. Eye biopsies will be subjected to formal saline buffered formalin. Cell cultures and chromosome studies will be subjected to Clark's fluid. And the small biopsies like a carotene will be subjected to Carnot's fluid. Okay. So these are the few targets and their fixators we can choose. Okay, tissue target and fixator. This table is very important. I may ask questions from this table in the exam. Okay, discuss in detail about various types of fixators used in immunohistochemistry. Add a note on target substance and the fixator of choice. Okay, if I ask such question, then you must write these two tables. These two tables are very important because you are masters, you are not BSc. So you must go through all these things and you must memorize. Okay, and I can also ask about a short question on what is freeze drying and what is vapor fixation. You must discuss about all these things. Okay, vapor fixation, here we will use this four vapors: formaldehyde, osmium, glutaraldehyde, and ethyl alcohol for fragile and weak tissues. Fragile tissues can be subjected to this vapor fixation. What is the temperature? 60 to 70 degrees centigrade for 2 hours will be the ideal procedure for this vapor fixation. So this is all about the vapor fixation. Anyway, so the first step in immunohistochemistry has been over, which is the tissue fixation. Then second step will be antigen retrieval. Okay, pre-treatment. Okay, now the antigens, yes, upon fixing even in immunohistochemistry, the proteins has been lost, the proteins has been masked. The proteins, there is a formation of sir, no battery. Yes, sir. Yeah. So yeah, so this protein crosslinks will be formed. Okay. So now, in order to retrieve the cross-linked antigens, in order to get the masked antigens back for facilitating the antibodies to bind, we must go with the second phase of tissue processing in immunohistochemistry called antigen retrieval. We have various methods to retrieve the embedded antigen within the tissue. So let me give you a summary of this antigen retrieval methods. In tomorrow's lecture, we will discuss in detail about individual method of antigen retrieval, individual procedure of antigen retrieval. Okay, so yeah, so Yeah, as we know that fixation will destroy the proteins, we need to bring back the proteins or antigens. That is the same story here. Antigens, the part of the antigen that will bind with antibody is called epitope. So we need to retrieve the epitope part of the antigen. So uh, uh, how we will bring back the epitopes? That is my question. So epitopes can be bring back by various methods. One is, see, these are the methods. We have proteolytic enzyme digestion method. We have microwaving methods. We have combined microwave and proteolytic enzyme method. We have pressure cooker heating method, de-clocker heating method, pressure cooker inside a microwave oven method, autoclaving method, water bath heating method, steamer heating method. Okay, so how to unmask antigens, how to retrieve the antigens. So these are the methods we can opt for unmasking or antigen retrieval, or to retrieve the antigens from the tissue. Okay, we have proteolytic enzyme, digestion, microwave, etc. And individual processes we can discuss in tomorrow's lecture. So what are the proteolytic enzyme digestion methods we have? What types of enzymes we can use in order to retrieve these antigens? What is their principle? What is their mechanism? And for what antigens we can use a specific type of this antigen retrieval techniques. Okay. So for example, proteolytic enzyme digestion is used for getting antigens. Um, and the enzymes that we are using is trypsin protease, chymotrypsin pronase, and proteinase K. And pepsin can be used as an enzymatic digestion method. So this we will discuss in tomorrow's lecture. So a quick summary of today's lecture. So in today's lecture, we discussed in detail. 1 second, let me go back. Yeah. So in today's lecture, we discussed about the three parts of the tissue processing. We have tissue preparation, tissue treatment, pre-treatment, and staining. Tissue preparation includes fixation, sectioning, mount preparation. Pre-treatment include antigen retrieval, inhibition of endogenous enzymes, and non-specific sites deactivation, and staining. So in tissue preparation, we discussed about fixation. Say, as we know that fixation is a method of preserving the tissue by forming protein crosslinks. Then we discussed about aims and objectives of fixation. Then we discussed about the properties of an ideal fixator, such as it should be cheap, easily available, stable, rapid in action, cause minimal damage to the tissue. It should not bind with the reactive species. It should have even penetration. It should not impart its own color to the tissue. So there are such an characteristics or properties that we need for an ideal fixator. Then we discussed about the amount of fixation. It is 1:20. For 1 gram of tissue, we should use at least 20 ml of fixator solution. Then there are certain factors that influence the rate of fixation, such as temperature, speed of reaction, the size of the specimen, and agitation, and even blood and mucus containing tissues will take long time for fixation. Then we discussed about various methods of fixation. We have physical and chemical. And chemical fixators, depending, there are three types: aldehydes, oxidizing, and protein denaturating. And depending upon the complexity, fixators are two types: simple and compound. Simple fixators include formalin, mercuric acid, osmic, picric acid, acetone. And compound fixators, in compound fixators, there will be more than one component. And compound fixators are further divided into three types: microanatomical, cytological, and histological, histochemical. Microanatomical, we have formal, saline, Zancas, Bowens, and cytological further differentiated depending upon two types. Either it is nuclear fixator or cytoplasmic fixator. Nuclear include Clark's, Carnoy's, Newcomer's, Fleming's, and cytoplasmic include Champis fluid, and histochemical. And then we discussed about various methods of fixation in immunohistochemistry. One is vapor fixation, where we will subject the delicate fragile tissues to the vapors of formaldehyde, osmium, tetroxide, glutaraldehyde, or ethyl alcohol. And we also discussed about freeze drying. Freeze drying is a method of cooling the tissue, making us a solid block, cryo block. Okay. So the advantages of freeze drying include excellent for enzyme studies, no changing of protein structure, there won't be any shrinkage of the tissue, and glycogen can be preserved in the tissue. Then we discussed about the overall classification of summary of the various types of fixators, their targets, and the fixator of choice we can use, such as protein, carbohydrate, lipid, glycogen, bioamines, myelin sheets, biopsies, lymph nodes, bone marrows, chromaffin, renal, testicular, eye, cellular, and other tissues can be how to subject these tissues to various fixators that we discussed in today's lecture. In tomorrow's lecture, we will discuss in detail about the antigen retrieval steps. What are the various types of antigen retrieval steps we have for treating the tissues? We already have a quick overview on these antigen retrieval methods, such as we discussed the proteolytic enzyme digestion, microwaving, combined micro and enzyme digestion, pressure cooker heating, Blockers heating, pressure cooker inside a microwave, autoclaving, water bath heating, steamer heating. All these things we will discuss in tomorrow's lecture. Okay. So this is all